All right, this is lesson 1.2, and we're looking at the distributive property. So, as we're looking at that, distributive property and inverse operations, and really getting into solving equations as kind of what we're building up to. So, first we have inverse operations, in other words, opposites. So, when we look at what our opposites are, opposite of addition would be subtraction. Opposite of multiplication is division. When we get into square roots, for instance, the opposite of the square root of something would be x squared. And then I want to say this one is written wrong because x to the negative first power is actually equal to 1 over x. And so the opposite of that, or the inverse of that, would really be just regular old x, or x to the first. If we're thinking in terms of how we cancel something out or move it to the other side of the equation. So on our examples, the opposite of doing plus 8 would be minus 8. The opposite of the square root of 7 would be 7 squared. And we do have a little note over here that's kind of good to take a look at, that if we have x to the third power, you have such a thing as a third root. And so when we're doing the square root of something, we're splitting it up into groups of 2. Doing the cubed root, we'd split it up into groups of 3. Fourth root would split it up into groups of 4. Continuing on, if we're dividing by 13, the inverse operation is going to be to multiply by 13. And then we'll just finish these out. Minus 8, opposite is plus 8. Opposite of 4 squared would be the square root of 4. And again, these are things that just cancel each other out, or give you the opposite of it for the purpose of moving it to the other side of the equation. Multiplying by negative 5. Opposite, of course, would be dividing by negative 5. And for 1/8, really you're just saying that's dividing by 1/8. The opposite of that would be 8, and so kind of multiplying those together. And the inverse, or the opposite of 9, then means that would be 1 over 9. Right, so we'll keep those in mind as we get to the solving equations portion of this. We're also going to look at a little bit of the simplifying here, particularly the distributive property. So when we're using that distributive property, we use the claw to take it and multiply whatever's outside here times all of the parts in there. Just a way to help us simplify and work those out. So we'll just hop straight into some examples. And so, sorry, I don't know if you could see that. This 5 is getting distributed out to those 3. So it's multiplying by every little part there. Okay, so on my first example here, I've got 3 times 2q plus r plus 5 times 4q minus 7r. So as it is right now, I have q's and r's, but they can't combine because they're inside a set of parentheses. So what I'm going to do is when I distribute those, it's going to get it to where I can actually combine them. So 3 times 2 gives me 6q And 3 times r just gives me 3r. Okay, 5 times 4 is going to be 20. So that's 20q. 5 times negative 7, negative 35. And that's with the r. Now we're going to combine like terms. So 6q and 20q and positive 3r, negative 35. As I go through and combine those, 20 plus 6 would be 26q, and positive 3 and negative 35, I'll do 35 minus 3 to give me a negative 32r. And now we're to the point where that is as simplified as we could get it. We do have sometimes where we might need to pull out a greatest common factor again for the purpose of simplifying even further, or for whatever process we might need to use it for. But for right now, we're just leaving it as that. Example 2 is one that goes through the same thing, just with, we got some numbers and some with the letters there. But I will look at example 3 just because it has this negative here. So all that means is that whatever is inside the parentheses is going to turn negative. The way I've talked about it before is that I'll turn that into a negative 1, and then I can distribute that negative 1. So from that, I get negative 3a minus 2. And then the important thing here is I'm going to distribute that sign along with that 3. Because if I don't do that, I'd end up with the 15a being negative, but the 35 being positive when it should actually be negative. So distributing this works everything out in the correct way. So 3 times 5 gives me 15, and that's with the a. And negative 3 times 7 would be a negative 21. And again, going through combining like terms. So I have my a's, and it looks like everything ended up negative here. So I end up with negative 18a and minus 23. Okay, number 4 is going through a similar thing. We'll work it out quickly. Again, we're going to distribute. And if there was more than 2 terms in there, just like what we've got up here is that kind of example, however many terms are in the parentheses, that's what we will distribute to. So going and multiplying 7 times 12, or negative 12, so that would be negative 84x, and then minus 21. And then this is a positive 10, so that means the signs will stay the same. So plus 60x plus 70, and then that minus 12 just stays on the end. So looking again at my terms, I've got a negative 84x, got a positive 60x. So that'll cancel a lot of it out and leave me with still negative, just negative 24x. And then here, positive 70, negative 21, negative 12. Looks like I would have a positive 37 there. That says 37. If I added the 21 and the 12 to it, should get me back to 70. So that actually simplifies down quite a bit for us there. Again, that's just distributing, and then we're going to combine like terms, or do everything, combine it like it needs to there for that. Okay, then on the back, now we get into some equation parts. And so this is really putting all of those steps together. So it's taking in if there's any distribution, we'll do that. But then we're also using those inverses to solve for whatever the variable is. So since we have an equal sign here and only one variable, that means we're going to solve for that variable. So going through this, normally, if I remember to, I'll draw a line down the middle. So that just reminds me that whatever I do on one side, I'll also do on the other. So if I subtract 2 over here to get rid of this 2, I'm also going to subtract 2 over here, which would cancel those out, get me 16 over here, and 4m over here. And remember, we're solving for that variable, the m, so I'm trying to isolate it or get it on its own. To do that, next step I need to do is I should divide by 4. And if I divide one side by 4, of course I got to do the other. And so 16 divided by 4 would be 4. And so I get my answer as m equals 4 there for that. Again, just doing the opposite steps, the reciprocal of those to help me solve it. And when I look at the example for number 6, they give us 4v plus 20 minus 6. So the very first thing I'm going to do is make it a little simpler by doing that 20 minus 6. Okay, because we can't do 4v plus 20. So we're going to kind of take away the 6 from it, combine those like terms. So positive 20 and a negative 6 would give me a positive 14. So now I'm at 4v plus 14 equals 34. And now I can start working on isolating that variable. Doing that, I would subtract 14 from both sides, giving me 20. And then just having a 4v left over here. And last step, since it's multiplying by 4, I'll divide by 4. And I end up with 20 divided by 4, which is just 5. So v equals 5 for that one. Okay, on 7 and 8, you've got a couple different examples of ones where you might have fractions or division. So here, the fraction part is separate. No simplifying to happen, so all I've got to do is start doing the opposites. So since it's minus 7, I'm going to add 7 to both sides, giving me 8 over here on the right, and x divided by 6 over here on the left. And in order to get rid of that 6 on the denominator, if I multiply by 6, that's going to enable those to cancel out. And so x here is going to equal 6 times 8, which is a 48. My next example is slightly different. So I'm dividing, I've got x minus 1, all of that divided by 7. So when I'm working this one out, the first thing I'm going to do is actually multiply by 7 in order to cancel those out. And so over here, I'll multiply by 7 as well. And then I'm at x minus 1 equals 35. And all that's left to do is add 1 to both sides. And when I add that 1 to both sides, I end up with x equaling 36. So not too bad, going through just the same steps. We're kind of working our way out from like farthest away from the variable all the way in. Okay, getting to like on number 9 and 11, there is some distribution that could happen. So you've got two different ways to work out number 9 here. First one would be to say, well, I'll use my distribution to get negative 5x minus 30 minus 10 equals 10. Combine some like terms to get negative 5x minus 40 equals 10. And then I'd add 40 to both sides, which would give me, I guess that's 50. And then negative 5x over here. And so since I'm multiplying by 5x, negative 5, I need to divide by negative 5. And what I end up with is, I'll run out of a little room, but that looks like it's negative 10 is my answer there. Okay, I do have another way I could solve this, as long as I don't end up with the zero somewhere, I believe, is I could start out in this negative 5x plus 6 minus 10 equals 10. I could go ahead and say, well, I can go ahead and start working from there and add 10 to both sides, which would give me 20. And then I have negative 5 times x plus 6. And I then divide by negative 5, which would give me negative 4. And so I'm down to having x plus 6 equals negative 4. And my last step there would be to subtract 6 from both sides to ultimately give me x equals negative 10. So either way I work that out, got about the same steps. It's one of those, if you see it one way versus another way, it might make a little more sense to you. So whichever way you work it out there absolutely works. Okay, on number 10, we're definitely in a scenario where you could work it out where we divide 4x by 8 and divide negative 16 by 8, which would give us a negative 2 here that I could put with this negative 10. Really, I think you're a lot easier off if we just say, well, negative 10, if I do plus 10 to both sides, gives me 6. And then 4x minus 16 over 8 would multiply by 8 to get me 4x minus 16 equals 48. Then, of course, I'm going to add 16 to both sides to get 64. And then last but not least, if I divide by 4, I believe that gets me 16. And so x would just equal 16. And that to me is a little more straightforward than doing a whole lot of organizing over here first, because you can just start chipping away at it and getting that. Okay, and number 11 goes through kind of the same thing. We're out of time on this video, so this is going through and getting you to where we are solving some single variable equations there.